Here we go, exercise 11I. Area between curves is what we're doing. Let's go. Exercise 11I, we're going to find out. Area between curves, in fact, it might be probably easier than trying to find the area of a graph only. When you have two graphs, it should be easier because the theory is just one theory and it makes it easy. The only problem is just being careful with your intervals. That's the only part. Okay? But here we go. To find the area of the shaded region bounded by two curves, okay, so meaning you've got f of x and g of x, they say it is the integration of f of x minus the integration of g of x. Okay, and that gives you the area between it. Now that kind of makes sense because if you found the integration, which is the area under the curve of f of x, this is the area you'll be finding. You're finding this area. So from a to b, you're finding all of this. And then, if you're finding the area of g of x, which is the blue curve, between the same points a and b, then you'll be finding this one. So I'm going to do, let's do green. Then the area would be that section there. So it makes sense that if you want the area of the yellow region, it would just be the red minus the green. So that means, and the theory only goes with this idea that as long as you have the upper curve, upper meaning greater y values, greater y values, so all these values here are f of x. These are the greater y values minus the lower y values for that curve, you will get the area between it. So why is that important and why is that cool is because you can have any graph. So you can have a graph that, like, let's go up, down, left, right, and then you have that. Okay? The nice thing is it doesn't matter if it's below the x-axis or not. The reason why is because the area is constant. It's always going to be between those two. So even if I shifted this graph, if I did a translation for both graphs, if I shifted the graph up, it's still going to be the same area. The net area, there's no net area in this case. It's just top minus bottom. The problem when I said that you have to be careful with the intervals is, let's say this is your f of x graph and this is your g of x graph. There's a difference here. From this point, which I'll call A, to this point B, this is now g of x. See, this is g of x curve. That's the g of x curve. Take away the area of f of x. Whereas on the bottom here, this is the curve of f of x, take away g of x. Okay, so that's the only thing you have to pay attention to, that the endpoints matter. But in terms of whether it's below the x-axis or above the x-axis, it doesn't matter. Whereas previously, remember I talked about net area, that it matters. The area, whether it's above the x-axis and the area that's below the x-axis, it mattered. Whether you have net area or total area. Then you had to worry about those, but now you don't. So when you're finding areas between two curves, the only thing you have to look for is the upper curve minus the lower curve. That will give you the area in between, regardless of whether it's below the x-axis or not. It doesn't matter. Okay, that's why it's easy, right? And the only hard part then that means is finding the interval. How do you find the interval? Clearly, it's where they both intersect. So why is it hard if you're doing an exam 1? Is because you have to find the point of intersection. So the point of intersection could be an x cubed with a log function or an exponential function, and it requires some algebra. That's the only reason why it becomes hard. But if you had a calculator, finding points of intersection is easy. Yeah? So that's the only part. In terms of this theory, that's all you need to understand. It's the upper curve minus the lower curve will give you the area between, regardless of whether you're below the x-axis or above the x-axis. It doesn't matter, because it's just the area between two curves. Does that make sense? All right, excellent. The rest, they're just defining what f and g are. So they're saying f and g are continuous functions, means it continues, and it's between a and b, and f of x, meaning the y values of f of x are greater than g of x. They're just defining it so that this makes sense. Okay? So let's do a couple examples then. Let's have a look at this one. Calculate the area of the region enclosed by the curves with the equation y equals x squared plus 1. So you've got a quadratic, translation up by 1. And you've got another quadratic, 4 minus x squared, okay? And the lines x equals -1 and x equals 1. So what are these two? These are your boundaries. These are your vertical boundaries. So it tells you your domain, and you've got your two curves. So if you actually sketch it, this is x squared plus 1, so it's moved up by 1. This is 4 minus x squared. Okay, and they're saying they want to calculate the area region enclosed by x equals -1 and x equals 1. So this is x equals -1, x equals 1. So this is my area. That's the region I want. Okay, so I'll just write here, this is x equals -1. This is x equals 1. This is x squared plus 1. And this is y equals to 4 minus x squared. Okay, so if we were to find the area between the two curves enclosed by that region, it would be the red curve, because it's the upper y values, take away the lower curve. Now the upper curve is 4 minus x squared, and the lower curve is x squared plus 1. So you're literally just finding area's integration or antiderivative. So I'm just saying integration from -1 to 1, which is my boundaries, -1 to 1. I want the upper curve, which is the 4 minus x squared, take away my lower curve. Now notice I put the brackets in case, because if you don't put it in the brackets, most students think it's minus x squared and a positive 1. So I put it in the brackets to make sure that you know it's minus x squared and a minus 1. Okay, and you find the integration or antiderivative, and therefore you get your answer. So let's try this one. We're going to do this one, you're going to try the next one. Okay, so here we go. Same thing, it's from -1 to 1. I'm going to simplify it, so it's 4 minus x squared, take away x squared, take away 1, dx. This is integration of -1 of 1. 4 take away 1 is 3, minus 2x squared dx. So now I simplified it. Antideriving a polynomial. So antiderivative 3 is 3x. Antiderivative of -2x squared is -2x cubed on 3 between -1 and 1. Okay, remember there's no need to put the plus c because they cancel out when you find the area between an interval or definite integral. Okay, so now I just need to use fundamental theory calculus, sub 1 in. So you sub the 1 in and you sub the -1 in afterwards as well. So subbing 1 in, I have 3 times 1 minus 2 times 1 cubed on 3. So this is my first one. F of 1, take away, I'm going to do another color. F of 2, F of -1. So 3 times -1 minus 2 times -1 cubed on 3. Let's work them out individually. So 3 take away 2/3. So that's 1. Take away, now that's -3 plus, is that -1 plus 2/3? There you go. Let's work that out. So negative with a negative makes it a plus. So you've got 6, because plus 3 makes it 6. And then -2 over 3 minus 2 on 3 is minus 4 on 3, which works out to be what? 3 times 6 is 18, minus 4, 14 on 3. There you go. Is that easy?
14 on 3 is what?
Unit squared, or squared units. Yeah, because we don't know what the units are. Quick and easy. Okay, so upper curve minus lower curve. The last example that I have, that would be a tricky one, but I want you to try the middle one. Okay, there's 3 examples. Here we go. You try this one now. Find the area of the region enclosed by the graphs f of x equals x cubed and g of x equals x. There's no intervals given, so you have to find the intervals given. Okay, so you need to know what your lower bound is and upper bound. How do you find that? Point of intersection. How do you find point of intersection? Solve when they're both equal to each other. So unlike the one before, there was -1 to 1. We have to figure this one out now. There's the graph in case. Oh no, whoops. I just realized it gave you the intersection point, so you figure it out. Remember, you only need the x values, you don't need the y values. You're just looking for an interval. See where the intersection point is. If you visualize it, it might make it easier. -1 is where they intersect, 0, 1. Cubic graph in a straight line. Now you're just trying to find the area enclosed, which means the area between those two curves. Did I just give you the... Here we go. Anyone going snow soon? I'm going next week, Friday. I'm leaving right after I finish my 5th session here, and I drive up there probably by night time. Sleep the night. Saturday morning up on the mountain, 7 a.m. and snowboard till 4:30, come back, rest for another night, and then Sunday snowboard till about 3 and get back by about evening. And then back on Monday with you guys again. For 2 weeks. I'm going to do that for 2 weekends. I'm going to figure it out. Or we'll get a textbook. Easy. The only difficult part here, got to separate your integration, separate into 2 parts. First one has an x cube on top, take away x, and the other one was x take away x cubed. That's the only difference. Okay. So if you did your integration right, let's work this out. You've got x to the power of 4 on 4 minus x squared on 2, -1 to 0, plus. Now you're going to do, what is this, x squared on 2 again, minus x to the power of 4 on 4, 0 to 1. Substitute them all in, that's 0, minus, now sub in a -1, we'll make it 1/4 plus 1 on 2. That one, plus, sub 1 in, you get half minus 1/4, take away 0, and let's work that out. What's that? If I times this by 2, 2 take away 1/4. Yeah. Yeah, right. Half. Hands up if you got half. Good. Try this one. This one's a hard one. The last one's a hard one, but other than that, these two should be easy. First one's revising inverse functions. Find out your inverse. Find out the antiderivative, means find the area. And then have a think about this one. Okay, so you got your function, log of x plus 1. If it helps you, this is the graph. Oh wait, oh no, I can't do it for you yet. Alright, guess you have to do A. Do A, find the inverse by swapping x and y. You forgot it. Swap x and y and find out the inverse function. So So A and B is doable. C, you might have to think. I just realized I got my answer wrong. This is part of my definition. Disappointing. Swap the x and y's. Inverse of log. Do the exponential on both sides. So I'll do it in red here. Exponential on both sides. Inverse of positive 1 on both sides. Don't leave your answers that in your exam. If they say find the inverse, make sure to do this, but this is where I went wrong. R plus. Okay, so write your inverse function as f negative 1. I'm just defining it. Good habit to do so if you're doing the exam. So that's part A. Once you got part A, now you can do part B. And yes, you can antiderive e to the power of x, and you can antiderive negative 1. Problem is C. You don't know how to antiderive log. Actually, it's not even R plus, isn't it R? It's R. Range can be all numbers. Yes, range is R. R maps onto R. For those who need visualization, that's the graph. You got log e of x plus 1, so the blue is your f of x.
Why does it only go to 0? Yeah, why does it so you can keep going? Pop beyond 0.
Which one are you talking about?
The graph.
Oh. Yeah, because the domain's R plus union 0.
Oh.
So actually my range here should now be, yeah, does log even, oh, because it moved across to the left by 1. Oh, of course. Okay, so it does include 0. So I was right. How about that?
You've got to teach it right.
It's right.
Teach it right.
I'm one that teaches you to learn for yourself. I'm one to teach you to learn for yourself. Well done, Karen. I've got 1. Show me R plus union 0. I was just doing the swapping. In my head it was like this. Alright, here we go. Let's do the second part. B. So doing B, you got your graph. you want to find 0 log e2 wherever 0 log e2 is, all the way, so this is the area you're looking for the F inverse, wherever log e2 is. So e to the x minus 1, 0 to log e2. Let's work out the area. And you derive e to the power of x is e to the power of x. And you derive 1, x using fundamental theory of calculus. E to the power of 0 is 1, so this becomes minus 1. E to the power of log e inverses one another, so you get 2 minus log e of 2. So if you simplify that down, integration should equal to 1 minus log e of 2. Hands up if you got that correct. Good? Excellent. Now let's have a look at C. What's the problem with C? Problem with C, we don't know what the integration of log e of x plus 1 is. We haven't learnt how to find antiderivative log e. So what they're really saying is, find the area between 0 to 1 of the blue line. You don't know what that is. Because you don't know what it is, because you don't know what it is, there is another way to do it. And the other way is you can find the area towards your y values. Okay, so that just means instead of doing dx, meaning instead of doing your rectangles along your change in x, you can do change in y. Why do you want to do that? Because you can actually rearrange your function log e of x as e to the x. That's what you can do. Okay, so you can find out the area of this if you rearrange it in terms of y. That's why you want to do that. Okay, so if we rearrange this to find out that curve, right, then you can say it's from 0 to wherever this point is. Now what we know is when x is 1, okay, so when x equals 1, when x equals to 1, it's log e of 2. So that means this is log e of 2 there. What I want is to find the integration of this curve here between 0 to 2. Now this curve is in terms of x. So if you swap the x and y's, because you're swapping the axes, if you swap the x and y's, which I'll do it over here, think of it this way. It is f of x, actually I'll use y for now. Y equals to log e of x plus 1. That's in terms of x. We don't want that. Because if we follow in terms of x, we're going to work with the x-axis. What we're going to do now is we're going to pretend that was the other way around. That if it's x, y, okay, from 0 to log e of 2, which is this point here. So if that was 1 as log e of 2, we're pretending this is your y-axis now. So that means your curve is going to be this part. Okay, so if you try to imagine it, it's sort of like keeping your head, it's kind of like that shape. You're trying to find that area there, which is here. Okay? The reason why you want to find that area is because if I draw out the box for you, see that rectangle? I know how to find that area of the green box. See, the area of the green box minus the area of the red is going to give me what I want. See, that's the area I want. So if I find that area of the red, I can minus the green. Now how do you find the green? It's just length by width. It's 1 times log e of 2. Okay, if I can find out the area of the red. Now the area of the red is just writing in terms of y. So that means I have to rearrange this so that I get it in terms of y. Okay, so I'm going to rearrange that. I'm going to say, all right, whoops. I'm going to rearrange this e on both sides, so e to the power of y, e to the power of log e, cancels out. So e to the y is equal to x plus 1. If I rearrange and write it in terms of x is equal to e to the y minus 1. Why is that important, even though it feels like you're just doing the inverse function? You're technically now saying, find the area, which I'll rub this off so you can see. I'm just saying, find the area of the same curve. I haven't changed the curve. Of the same curve, but now I want to integrate it along the y-axis. So that means you're saying find the integration of e to the y minus 1, no longer dx, it's now dy. And that's why it's a change in your rectangles along the y-axis. If you want to think of it another ways, I'm just changed the x to be the y-axis, and I've changed the y to become the x-axis. So this is what I'm trying to find. Change in y, and I know it's from 0 to log e2. Okay, that's all I'm doing there. So this is where 1 used to be. That's where it used to be. I'm just now integrating along this side here. So this is easy. Why is this possible to do? Because I do know the integration of e to the y. I didn't know the integration of log, but I knew the integration of e. So I can now do that. So if I do that, technically if you think about that, this is exactly the same as this question. That's why they gave you b. It's 0 to log e of 2, e2 instead of the x, it's meant to be the y. So I know the answer should still be 1 log e2 is my answer. Okay, so just for argument's sake, just so you can see what I'm doing, I'm just going to do it all again. So now we're trying to find integration from 0 to log e of 2, and we do the same thing, integrate e to the y, which is e to the y, minus integration of 1, which is y, between 0 to log e2. Okay, and that, using fundamental theorem calculus, sub y in the y values, because I'm substituting from 0 to log e2 there, log e2. Okay, and we know that that final answer should be 1 minus log e of 2, based on our previous answer from b. Okay, and so right here, that's not our answer, that's not our final answer. Remember, we found out the green. What we want is we want to find that area underneath the blue. But it's easy to find because we know this rectangle is the entire area. If I minus the rectangle, minus the green from the rectangle, I'll get that leftover region that I want. The rectangle's easy, it's just area of rectangle is length by width, and it's 1 times log e of 2. So your final answer would be rectangle minus green area. So area of rectangle is log e2 minus 1 minus log e2, and your final answer now becomes, what's that, 0, which? No, yeah, 2 log e2 minus 1. Okay, so that's why it's tricky. The tricky part is you didn't know how to do integration of log e, you have to do it the other way. So if you can't do it along the x-axis, you have to do it along the y-axis. That's why that's tricky. Okay, so that's example 30. If you want to have a look at the solutions again, or watch this video again, but that's what they did. They were trying to find it along the y-axis. Other than that, there you go. If you're interested, there's a VCA question here, otherwise work in your textbook. Same thing. Exam 1, 2007, question 9, same idea. We'll work on that. We'll probably finish early today.
How early?
I reckon 10 minutes. 3:50 is good.